understand the objective, which are to improve the response. It starts by collecting data from various sources, then normalize and analyze the data collected to evaluate the current limitation of SIEM solution to enhance the detection performance, and finally to build and test lab environment. Now we have defined the introduction. We will move to the background section where I will give clear understanding of the technology used. First, we have SOC, which is Security Operations Center. That include people, processes, and technology used to monitor, detect, and respond to cybersecurity threats. They operate 24/7 and use, as we can see in the following picture, the key function of SOC include monitoring and responding to threats, and to use threat intelligence to stay updated. We will focus on the SIEM, which is Security Information and Event Management. They collect logs across the organization infrastructure to detect anomaly and raise alerts. It has two main parts: Security Information Management and Security Event Management. Now it is important to understand how SIEM actually works. It starts by collecting logs from various sources, then use rules to detect anomaly. If threats found, it will generate an alert. Finally, the data is saved for future use. We will move step by step for each process. First, the data is. Second, the process of data normalization, which means converting log from different sources into one and single format for easier analysis. Then group similar events together to reduce duplicate and noise. After that, the event correlation, which means connecting related events from different systems. And then, if threats found, it will generate an alert or take automated response. And finally, the data will be stored securely for long-term use. Now, it is important to understand the benefits of using SIEM inside an organization. SIEM is not help to detect threats, but also to respond to them. We give clear understanding of what happened. There are two types of SIEM solution. First, the commercialized and open source. Commercialized, used by large company, and they are expensive and generally need a license. Like IBM, Radar, and Logarithm, and open source, which are free to use and offer good flexibility, include Elastic and WASO. After setting up the system, the next question is how can we make the system more performance? This means optimization, where a well-optimized SIEM helps to detect threats faster, reduce false alerts, and improve performance. Now I will move to the project development methodology, where this proposed solution aims to help information system analysts to secure the system. It will give a clear understanding through a centralized dashboard, which improve the decision making and will enhance the control over IT assets. To enhance the detection and response capability of our SIEM, several powerful tools are used. For example, Suricata, which is a network intrusion detection system that monitor network traffic in real time to detect anomaly, and Yara to scan endpoints by using rule target identify and find suspicious file. Also, VirusTotal to check suspicious file and hashes using a multiple antivirus engine. And we have Alien Bot Reputation database that identify known malicious IPs or domains using reputation data. We have the Hive as an open source and incident response platforms that help to analyze and create cases. And finally, Shuffle for automated and response to actions. The main contribution also consists of connecting VirusTotal and reputation is to enrich the alert with more information, and then adding Yara rules to detect advanced malwares. Then for case management and testing, the integration of the Hive which allow to manage alerts and test the rule accuracy, to finally automate the response to incidents by using scripts or shuffle. Also, for the core improvements, we create custom rules to detect more complex attacks. Open source solution also was the most suitable option. It is an open source host-based intrusion detection system that detects threats and prevention help-to recognition is used by many organizations. As we can see in the following picture, the key component of WASO include the agent which is installed on the monitoring endpoint. They collect logs and send it to the manager. The manager, which is the brain of the system, they use decoders to understand the log format, then apply rules to detect anomaly. Also, we have the dashboard, which gives a clear understanding and visualization of threats. WASO has many features, include the integrity monitoring, threat detection, compliance management, and incident response. This diagram will show a global architecture of the optimized open source SIEM platform, when we have the agent that collects logs and then send it to the manager, which will use rules to detect threats. It's integrated with the external tools like Shuffle and the Hive. If threats is confirmed, it will generate an automatic response. Now I will move to the test and results part. To verify the system, I created full lab environment and simulate several types of attacks. This is important to keep track of each machine security status. And here we can find the dashboard where WASO find more than 21,000 alerts. From the alerts, there are 12 with level, there are 600 with 12 or more level, which mean serious alerts. WASO also identify and classify tactics used by attacker, including the initial access or privilege escalation. Threat hunting dashboard is used. It helps security teams to investigate threats more deeply. But who can access what? So WASO use rule-based access control, where administrators have full access and the read-only user can just view the dashboard without making changes. It depends on the rules, but also gives us the ability to create custom rules which enhance the detection. I will create several attacks. We will talk about some of them. First, for brute force attack, which means an attempt to guess a password. WASO will reply to this by creating two alerts, one for non-existent user and other for login failure. To test file integrity monitoring, I changed the important file where WASO successfully detects that change and generates an alert, as we can see in the following picture. Now the Hive, which uses to create and manage cases, it's received alerts from WASO, where when serious alert is detected, it will be forwarded to the Hive as a new case. Security analysts can see the attacks on the dashboard. It also can keep track and check the progress of each task or case created. For testing the Shuffle, I created a workflow where WASO alert sent through a webhook. It also sent to the Hive and various total to check for enhancement detection. If alert meets certain conditions, it will send an email notification to the team. So in summary, we can say that the optimized SIEM platforms is work well by identifying a wide range of threats, combining real-time alerts and dashboards and endpoint visibility to improve the detection and response to cyber threats while staying scalable and cost-effective. Our solution could be enriched by several improvements that can be made. For example, the integration of machine learning for anomaly detection to enhance the threat identification. For the solution can be enriched also with using distributed deployment instead of a single deployment. Our solution was not cloud-based, so we can make an integration with cloud-native services like AWS and CloudTribe. And finally, thank you for your attention. I hope this presentation gives said that how we can optimize SIEM platforms. Thank you once again.